I'm not sure if I have like the correct definition of AI, but I think the most popular one is AI is just basically trying to mimic human behavior.
Hello, friends. Welcome to this new episode of Gems Makes podcast. Today we are hosting Yahia Boudah. Hello, Yahia.
Hi, how are you?
Right. Really good. Thank you. Yahya and I are friends since 2016. We have met in online first in 2016 when a scientific contest held by the U.S. Embassy was launched here in Algeria, and we participated both. And it was about making a video of explaining a scientific concept. We both participated, and we both won a trip to the U.S. to the NASA space camp in Alabama, Huntsville. So Yahya, do you remember those days?
Yeah, those were really fun. Yes.
Yeah. So what did the US trip add to your life?
I think definitely ask more questions and be a lot more skeptical. I mean, I'm a lot more skeptical right now than I used to be before that trip.
Yeah. So you're
Yeah.
becoming more scientific in sort of a way.
I guess I'm challenging my own ideas all the time. So I try to read more and right.
Yeah. You just discovered that you are learning. Even if you're learning a lot and you're making some good efforts, there are people better than you. So you just try to catch up and try to learn more, try to question more. So that's for me how I feel after coming home.
Yeah, I mean, there's so much that you can learn. There's so much that one can learn.
Yeah.
So it definitely encouraged me to learn more about space and about everything.
Yeah. So do you still have the same relationship with space and I don't know, planets, comets, and all those, or did you just dive into computer science and forgot about space?
I wouldn't say so. I mean, the 2 years after that trip, I became a total space nerd. I mean, I would read books about astronomy and the history of science and all that pretty much every day, or just most days of the week. But right now, I'm focusing on probably the human brain or just AI in general. So this is what I'm spending most of my time on.
All right. So after that, you had your baccalaureate exam, and you have chosen to pursue computer science. So why did you choose computer science in university? Yahya?
Well, I guess the first reason is I've been using my computer for almost a decade now. So I spend a lot of my time on the internet. Back then when I was a young teenager, I used to do a lot of digital art. And then I moved into programming and doing all kinds of things. So I kind of enjoyed being with spending time on my computer. And the other reason is actually there's two more reasons. So the second reason is the problem solving aspect to it. And the third,
Algorithms, writing algorithms and solving problems,
right.
puzzles, and all sort of things. Yeah.
And the third reason is definitely, I think, AI. I mean, it just felt like the right thing to do right now.
So we've always liked the human brain, how it works, how it processes, data, how we think, how we recognize things, and all those things. And now you are, I can say, an AI enthusiast. Can you give us some definition of artificial intelligence, Yahya?
I'm not sure if I have like the correct definition of AI, but I think the most popular one is AI is just basically trying to mimic human behavior, or it's just trying to it's just the belief that human thought can be mechanized or can be automated.
Okay,
Right.
I would say more of automated because if we talk about mechanics, we would slightly go to robotics, don't you think? So I guess
Yeah,
robotics are about the physical part of humans, and AI is about the brain of humans. I mean, the thinking part of humans.
yeah, there's definitely two sides to it. There's the mind and then the body. And when talking about the mind, what I meant by saying mechanized thoughts, I meant that human thoughts can be something that is quite understandable, or it's just something that is super rigid. It's not something that's
Hmm.
fluid, or it's not something that you can. I mean, it is. It's not something that you can. So far, nobody has ever been able to demonstrate that human thought is something that can be automated, or that can be
Hmm.
mechanized. Right. That's
Yeah,
right.
yeah. Maybe because we had some sort of fear against that. We usually think of it as a Terminator movie. Well, machines will decide in our places and all that. So before just going to the perspectives of AI and the dangers of AI, I would like to go to definition because I usually on this podcast I start with definitions. So I found a definition here. So artificial intelligence is an area of computer science that emphasizes the creation of intelligent machine that work and and reacts with the humans. So it is about working and reaction with the humans. So this is why we need machines. And so when we say reactions with humans, that means that humans once had the desire to make machines, to talk with them, to help them study, work, and do their tasks. So, can you talk a bit about the history of AI and how did the human desire start to start making algorithms or intelligent algorithms that we call nowadays AI?
Right. I guess the history of AI, are just the idea um, of machine just goes back. It's a really old idea. It's in no way new.
Hmm.
Um, right. It just goes back all the way to the Greeks. Um,
Oh, really?
yeah.
But they
Uh,
didn't have computers. They didn't have the Turing machines at the time. So
they didn't
those
have
were
computers.
perceptions. All right.
Yeah, they didn't have computers, but they just held the idea that they can sort of. And
Mm-hmm.
I keep just getting back to this. They held the idea that they could mechanize human thought. They can sort
Mm-hmm.
of um,
Yeah, they can reverse engineer the brain, the human brain, I would say.
yeah, something like that. Or maybe they could understand what causes their thoughts to arise, or
Mm-hmm. Mm-hmm.
just create a theory of the mind, so to speak. But the more recent, I would say that AI, like the real artificial intelligence that you use computers to test it on, or you create algorithms to, test on your own computer, that just started like 70 years ago. It was in the 1950s, I believe.
Mm-hmm. All right, because I was just reading something on Google not long ago, and I found that it started around 1958 for the neural networks, and some people say also that Turing has some predictions about it. Did you hear about that? I mean,
Yeah, right.
Turing, the father of computation.
Yeah, he is. I believe he published a paper. I'm not sure. He probably published his very famous paper in the 1960s. But before that, it wasn't. Before neural networks came along, really, it was more. AI was mostly symbolic, so it was completely rule based. You'd have these systems that you would literally just hard code with human knowledge, um, in just really simple, dumb if then statements, and then you'd use that to sort of answer
Hmm.
questions or do all that kind of stuff.
Hmm. Yeah.
So yeah, I mean,
So yeah,
uh,
go ahead.
there's a lot of things that just came out of that. So, for example, there's the Eliza, which is like a chat bot that just fools you into thinking that it's a human that's talking to you, but it's super dumb. I mean, if you just go on YouTube and actually type Eliza and see what it's like, the answers to the chat bot, they seem they seem programmed. They're not in any way genuine. They're not. I mean, they seem like they were hard coded by a
Hmm.
human. So
Yeah. Yeah. So when we see this sort of I don't know these projects, we sometimes may say we are still far from reaching our goal of making natural like react I mean interactions with machines. But sometimes when we see, I don't know, YouTube giving you exactly what you need to get, like through your last research, your last I don't know podcast that you have been listening to, your last YouTube watches, they can just give you exactly what you need. So at that point, we say that artificial intelligence is really reaching a really good point. But sometimes when we see the Lisa, as you say, or I don't know, some models that they really don't really meet the our expectations, we say we're far. So what do you say about artificial intelligence? Are we in good advancement, or are we still far from our goal, or what is the goal of AI first?
Well, I'm not an expert, but from what it seems to me, I don't feel like at this point, I don't feel like anybody really knows what he's doing. A lot of people are just trying so many different approaches,
Mhm.
but no one has really got the ultimate answer to creating a really intelligent machine. So you have so many attempts in
Mhm.
computer vision, in natural language processing, in robotics, but nobody has ever been able to come up with something that encompasses all of these things. I think that's like going to be really difficult, and maybe it's going to emerge out of developing each one of these parts separately. So
Exactly. Yeah. I was just talking about this thing because people usually confuse a an AI algorithm with the whole with all the functionalities of your brain. So the most successful projects that I see right now, they just take a part of their brain, they just tear it up, and they try to build an algorithm based on those aspects. If I give you an example of the self-driving, the Tesla self-driving cars, they're really making some really good investment. Can you just imagine going from, I don't know, LA to San Francisco without touching the wheel? It is just amazing. But if we go to the attempts to make a whole brain at once, they usually do not succeed. So you say that it's better to separate the parts and try to work on them
yeah, right. I mean,
separately.
there's currently a lot of successes in narrow AI, so you get it to perform really well on certain narrow tasks, but you can't get something that can get literally everything done. Uh,
Mhm.
from helping you do your homework to driving your car to
Mhm.
talking to you, all that kind of stuff.
Yeah, so sometimes we need, maybe scientists need to reshape our imagination of the future. Because if you go back 10, 20, 30 years ago, they could imagine that in 2020 we would have flying cars, I don't know, some flying boards, but that is not the case. We are not working on that aspect of technology. We are more working on a software development. We are more working on intelligence development. So I guess sometimes we make some wrong predictions of the future. So I think that that happens. The same thing happens with AI. So we
Yeah,
cannot really predict what we are going to make in next years.
yeah. I think you never know. I mean, you never know whether AGI is just going to emerge in the next 10 years or it's not going to emerge ever. All you
Mhm.
can do is just work on the problem that you're facing right now. So
Yeah. So you talked about neurons. So one of the basic approach that scientists use are the neural networks. So can you briefly tell us what are the neural networks?
well, it's a technique that was developed back in the 1960s, and it started out as just this really simple, layer of, basically a bunch of neurons, where scientists were feeding it. Basically, each neuron would hold the value of the pixel of an image, and then you just kind of predict what that image is. You'd adjust the parameters that link the neurons.
Hmm.
As you give it more and more data, you just kind of the perceptron learns on its own how to recognize future images that it has never seen before. Of course, this is how it all started, but right now it has there's a lot to it right now. So if you know if you want to know, like, what do you want to know? Do you want to know?
Yeah, how it works? Like, what is I mean, an overview of the algorithm. I usually see on some animations those layers of neurons. I mean, sort of passing data from a layer to a layer. Like, I want to understand what are those layers and what makes the decision at the end. So, how does the computer know he's wrong? I mean, the computer knows it is making a right mistake or a wrong mistake, or a right decision or a wrong decision.
Right. I mean, there's a lot to it that I don't think we can cover in this podcast, but I will try to make um I will try.
Yeah. In a nutshell, like in a nutshell, how do those neurons, those layers work?
Okay, so there's probably two sides to understanding how the super simple version of a neural network works, which is like a standard vanilla neural network. There's obviously more. There's other versions of neural networks like convolutional neural networks, recurrent neural networks, but I'll just stick with the really simple neural net. So basically, I'm going to start with the intuition part. So the intuition of this is, imagine you have an image, right? Um,
Yeah. A
let's
dog
take
or a cat. A dog
right.
or a cat.
Yeah, we can go with the dog or cat, or maybe we could just go with a much simpler example, which is just a digit. Let's say that you have a picture of a digit, right? A
Mm-hmm.
zero,
Mm-hmm.
or let's say a one, and you're trying to train this neural network to recognize this digit, right? So you're trying to make it learn what that digit is, so that when you show it an image that contains a digit two, it just tells you or gives you a score that's close to one, from 0 to 1.
Mm-hmm.
So the first layer is basically just the input. So it's all the pixels that make up the image, right?
Mm-hmm.
And then as you move through the layers, every layer just contains some sort of high level information about what's in the image. So let's say the second layer, the first neuron contains information about certain edges in that digit. And then the 25th layer, let's say, contains
Mm-hmm.
information much higher level. The most high level information exists in the latest layers of the neural network, in the last
Mm-hmm.
layers of the neural network. So that contains information about, let's say, there's a curvature at the top. There's probably a line at the bottom. There's a curvature right at the center of the image. And
Mm-hmm.
so you could just sort of like see how you start out with these raw pixels, and then as you move through the network, as you progressively move through the layers of the network, you start to build up high level, just high level information about what's going on in the image. So the neurons in the last layers just contain information about, let's say that the value of the neuron in the last layer is 0. That might mean that there's no curvature at the top of the image. And then another neuron's value is 1. That might mean that there's a line right at the center of the image. This is like a really crude explanation, but
Yeah.
I feel like this is probably like the intuition part.
Yeah. So
And
yeah.
right, there's the second side to this, and it's purely mathematical. So it's not um it has nothing to do with the intuition. So this is purely mathematical. Imagine that you have a neural network with one single hidden layer right in the middle, and just one input and one output. Can you imagine that?
Yeah, I can. Yeah, I do.
Okay.
You did not mention what are the hidden layers. Maybe the auditors or the listeners don't know what are the hidden layers. So the hidden layer is the layer in a neural network schema that you find in the middle. You have the entrant layer. Is that its name? And
There's
the
there's the input layer and then the
the
output
input.
layer.
Yeah, the input and the output and the hidden in the middle of the schema. So just to
Right.
imagine.
Everything that comes in between is just the hidden layers.
Hmm. Yeah, go back. You were talking about the hidden layers and
Right. The hidden layers is actually like the reason why they work in the first place. Mathematically, it's just all it's trying to do is it's just trying to approximate a nonlinear function, and maybe that's just too much jargon for some people. So I'll just go ahead and explain what that is.
I mean, like maybe the listeners they will get bored, so we can go on jargon, I guess. We can go on simplified concepts. It's better.
Right. So it's almost like you have. Um, okay. So imagine that you have like. Okay, hold on. I don't know how to put this into words, but just give me a second.
Yeah, just take your time. Yeah, no problem.
Okay.
Hmm. So it has something to do with probabilities, right?
Well, some part of it does with the activation functions in the neurons. So basically what you're trying to do is you're trying to get, let's say, a table of inputs and outputs, right?
Mm-hmm.
And that's like your data.
Mm-hmm.
And
All
then
right.
what you want to do is you want to find the function. You want to figure out the function that takes you from X to Y.
All right.
Right. So,
So we want to find that function, right? We're
like,
looking for it.
yeah,
Okay.
like it's, a super easy example of this would be, let's say there's a table of X and Y values, and the X value is 1, the Y value is 1, the X value is 2, the Y value is 2. Function is pretty obvious. F of X is equal to X. That's like a super easy thing. But when you have like a lot of different values in your table, and you can't really see a relationship between your X and Y variables, it's like obviously pretty nonlinear. That's when you need a neural network to approximate that nonlinear function that maps the input to the output.
Mm-hmm.
Right. So every time you feed your neural network with an input, every time you feed it, and then you get some kind of output.
Yeah.
Right. So when you get to that output, uh, what the algorithm does then is it compares it to the right output. And then when it does that, it tries to adjust the parameters, these
Right, the
weights, these
right
connections.
answer. Yeah. So they keep changing the parameters, right?
Right. They keep changing the parameters. Every time you feed it with some data, it nudges the parameters, the weights and the biases, until it gets the right output. And then over time, you could see, I mean, there's this fascinating animation that I found on this website. It's called, I believe, deeplearningandneuralnetworks.com, or maybe it's neural networks and deeplearning.com.
Mm-hmm.
And there's
So
this,
they can see the working process of the
yeah,
layers. I mean, how to change parameters and get the right answer.
right.
I've seen.
When you look at a one-dimensional function, it's really easy to see when the parameters change. You can see how the shape of the function changes to fit the data points on the 2D plane. I mean, on the 2D graph. I'm sorry.
Yeah.
So it's really. I mean, I think that's like a more mathematical explanation of what's
Mhm.
going on. Obviously, you can't really picture what's going on when you just have, millions of neurons in the input layer. But a really simple version of that is just one neuron, one
Mhm.
input neuron.
Good. 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 So I just wanted also to know more about the areas. As we know, usually there are three main popular uh, areas. We have our branches, we call them. We have the supervised learning, unsupervised learning, and reinforcement learning. Talk about the most popular one, I guess it is the supervised learning.
Yeah, I would say like I think these are like subsets of machine learning, I believe.
Hmm.
Uh, so, when you think about AI, there's like so many branches, so many people are doing so many different things that you can't really, I mean, it's a lot of different,
Yeah,
you know,
you can make it out in three main branches. Like people are doing a lot of research everywhere.
yeah, but the hottest topic as of now, as of 2020, is machine learning and, more
Hmm.
specifically, deep learning. So, yeah.
Hmm.
Um, so what do you want me to talk about?
I mean, talk about the maybe we start with the with so first, where do we classify deep learning and machine learning, or are they now branches by themselves?
Well, machine learning is just a branch of AI, and deep learning is like a subset of machine learning. So it's just
Hmm.
part of machine learning.
So I have some information. I don't know if it's right or wrong. I just want you to check this. So is machine learning the one that maybe we make a model, a training model, something like that, and then we train that model, and if it makes mistakes, we try to shape that, and then something like this. So we create the algorithm, and we have the data set, and we have a training model.
Right. I mean, it's something along those lines. Yeah, it's just basically of your model or like a certain you have certain structure to your function, right? You have all these weird random parameters, and then you have a data set, and you want to refine those parameters so as to come up with a function that makes better predictions.
Mm-hmm. And about the supervised learning, so it is usually defined as a learning function. I mean, that maps an input to an output based on an example input-output pairs.
Yeah, that's exactly what it is.
Mm-hmm. So, can you just give us some examples of supervised learning uh, algorithms?
You mean like real world applications
Yeah,
or?
real world application, exactly.
Well, there's actually so much. There's
Maybe self-driving cars, voice
yeah, definitely
recognition.
self-driving cars. The Tesla Autopilot actually uses convolutional neural networks to do this. They have a super gigantic convolutional neural network that that's just eating up data all the time and training all the time.
Mm-hmm.
But yeah, there's also self-driving cars. What else?
Maybe voice recognition, image recognition.
Yeah, I mean all those things. Text recognition as well.
Yeah.
Uh, yeah, it's all over the place. I mean, you don't really find. It's not just convolutional neural networks. You could find a lot of other variants as well. It really depends on the application.
So when we talk about machine learning, I've noticed that we talk a lot about recognizing. So is recognizing a key functionality for the human brain, or why did they pick only recognizing? Is it like, as I said, a basic and fundamental activity for the brain? Why don't we move to processing data? I don't know, like consciousness or the brain has different activities. So, what is the importance of recognizing things for you?
I guess this is like a question that I've been pondering for months now, and um, I think yeah. I mean, probably the only reason that people are so caught up with recognition right now is just, well, first off, because you need it for so many things. I mean, we could recognize dogs, objects. We could recognize a lot of things, but we don't just recognize things as humans. I mean, one of the problems that I have with deep learning and machine learning in general is that, let's say that you're trying to recognize a certain, let's say that you're trying to recognize a car. I've built a model that recognizes cars, and let's say I'm just feeding this model an image of a car. Um, and if you feed it like millions of images of cars, it's just going to give you some pretty good accuracy. But let's say that you take the wheel out of that car.
Hmm.
Are you following?
Yeah, I'm following. Yeah, just like feeding the model with car pictures, and then taking out the wheel. Okay.
Right. Let's say that you bring in an image of a car without wheels. The model is probably going to classify the image as a car, but it's going to give you a 90%. It's probably going to tell you that this is like, it's probably like a 90% chance that this is a car, or an 80% chance,
Hmm.
just because it is missing wheels. But if you're a human, you don't actually, if someone just brings a car without wheels, you're not gonna tell that person that this is a car. It's probably 80% a car. I mean, that's ridiculous. You're just gonna say this is a car, but it is missing wheels.
Hmm.
So I think this is like a main difference between the current models and just how humans usually just perceive things. We usually, there's so many approaches to computer vision, and the one that seems to work right now is the supervised learning approach. It works really well, but the only problem that I have with that is that we humans don't merely just take in all the
Much
photons.
data, maybe. Like it consumes a lot of data. What do you think?
Yes, and it doesn't really know what's going on. We humans, we probably don't take in photons and then we multiply their values by I don't know, parameters, and then we just recognize things. We actually construct, what's in the real world, right?
Mm.
So if I give you, if you see a car, you take in all of that rich data, and then you try to create a sort of high level representation of that car. So you just
Yeah. So maybe.
you understand what's in there. You understand that you understand every single part of what's going on. But when it comes to current machine learning methods, you just have this really black box, and you don't know what's going on inside.
Hmm. True. True. And some people give an example of that. Humans, they just learn. They are more efficient at learning, and they have tendency to say that machine learning is just stupid, just as machines used to be. Not stupid in the way that we don't that the algorithm does not think, but stupid in the way that it consumes a lot of data to learn just to learn a few things. So I guess you can give us some numbers how an efficient model can say that a dog is a dog and a cat is a cat compared to a human. Like if you grab a little kid that has never seen a cat or a dog in 2 3 pictures, you can just get a I can say 100% accuracy. While for algorithms, maybe tons and tons of data, and you still have a lack of efficiency.
Yeah, right. This is an ongoing debate about whether
Should we invest more or should we change the approach?
I don't really know because when you think about biological organisms like humans, the entire structure of our brain is just fundamentally different from that of a computer. So I'm not even sure if there's ever going to be an approach that's going to beat or that's going to reach sort of
Human
like
level intelligence.
human level vision, for example. I think we can get really good. It can get really good,
Hmm.
but it probably can't entirely simulate until unless you reverse engineer the human brain. But you probably can't come up with something that you can run on your computer, like an algorithm of some sort that could, entirely mimic the actual biological process that's going on in our brains.
Hmm. But before trying to mimic in the, as I said, the technical side of the brain, I guess there is first a philosophical debate about like how can we recreate the consciousness if it does exist. So I guess we need first to define consciousness and try to understand the depth of that and how it works and how to make something think. As you said, like these algorithms are sort of black boxes. You just don't understand what's going on. They do not process thoughts. They just the the robotic way. You have an algorithm model, train your model, give the result. So we are, I think, away from mimicking the consciousness, which means we are away from mimicking the human brain. What do you think about consciousness and the brain?
I don't think I know anything about the brain or consciousness, so I don't really feel qualified to answer that question. But I can tell you the major three approaches that people who are working in AI are following. At least when it comes to the mind, excluding robotics. So the major three approaches that people are following are self-reflection. This is the first one. So you just reflect on your own thoughts and you watch them as they go. And based on that, you just try to create algorithms that mimic your own thinking. So if you think about symbolic AI or just rule-based systems, things like expert systems, just use that. They just try to think about how do I think about this, and then you try to take that process and then you just try to mimic it using an algorithm.
Mhm.
Um, and then the second one is just following certain mathematical models, things like neural networks. So it's just pure math. And then the third approach, which I don't think that anybody has ever been able to successfully, make any meaningful advances in, is reverse engineering the brain, and
Mhm.
that takes like a shit ton of compute power. And
Yeah. And talking about compute power, I went to get out
yeah,
of bed.
people are not really, no one really knows what consciousness is. I mean, no one can give a proper scientific definition of what consciousness is or what the brain really is. But these are like the three major approaches that people are trying, taking to
Hmm.
recreate whatever this is.
Hmm. Yeah. Yeah. The human consciousness is still a problem there, as I said. Like, should we give a machine the power to decide? Do you think that it's possible one day to have a machine that decides on its own?
Okay, I've been answering too many questions, so I'll let you answer that.
Well, I think that I don't know. I have a problem first with consciousness, and I'm not really sure if we can remake that or if it exists or any sort of that. But I think that we are still away from making a machine that that makes decisions on its own. Like as simple as that. We are still away. Like seeing the models that are exist on the market, that exist on uh, on universities right now. We still, and I think it would be a good thing, but in a limited way. I don't think we should give the free will. I don't know. I feel afraid about that. I don't think I can give a free will to a machine, and yeah, that's it.
So, what do you think? Let's say that you're creating an AI system. What kinds of decisions would you, have it make in the first place? Like, imagine right now a certain decision that's being made by, a human being, like a politician or a president. Would you
That is the
would
problem. It's just a problem of trust, I believe.
you outsource
I
that?
cannot, I cannot trust the machine. Maybe some generations later they will trust the machine. For example, I give some data uh, of a presidential elections candidates, and I wait for the machine to give me the result. Like, would I take that into consideration? I don't know. I mean, given the Trump data for the last 40 years and the Joe Biden data for the last 40 years, and then let the machine decide. I don't think it's possible to trust the machine.
Right.
So I think that there are some human decisions that should be automatized, but some others that should be led to the humans. I think I'm really against automatizing everything and not automatizing everything. We should think wisely the tasks that should be automatized, mechanized, so we don't fall into a Terminator scenario.
An AI takeover.
Yeah, an AI takeover.
So,
So,
but I think if we are actually capable of creating an AI that's fully understandable, that we understand, how it works,
mhm.
uh, then I think like a rational AI could totally make many decisions that a president could make. I mean, let's say that you have a pandemic like the coronavirus right now in 2020. One of the mistakes that Trump made was that he had a really delayed response to the pandemic. And I think like an AI system would probably not make that mistake. It would buy the damn ventilators before it's too late. It would save, so many lives. Yeah, because, when you're a president, you have a certain freedom to do something stupid, right? But
Yeah,
when you're an AI, I don't think that you like if you're super rational, people are gonna die. We need to put money uh, into this area to save lives, and that's just gonna happen without any delay. So
true, true. Like human stupidity has no limits, just like Einstein said.
yeah, because if you have like a super rational AI, then
True, true. Totally agree. Yeah. So yeah, so if we make some rational creatures, or let's say machines that give us good decisions, that would be really good. I mean, even humans they can use them, so they can just put a computer in the White House and I don't know, let the computer decide. That would be good. Or just take
it could
into
help.
consideration the decision. I mean, before taking the decision, you have the political decision, the board decision, and you should add to that the computer decision. I think that is one of the perspectives I have about computer science, about AI.
Yeah, of course.
Mm. We can really that can serve as a good thing for humans.
Yeah, it could
Not-
definitely.
mhm. So so these are the perspectives. Anything to add, Yahya? Anything to maybe you can add some tips to learn AI, to learn machine learning, to learn programming. What do you think?
I wouldn't say that, I'm not super. I mean, there's plenty of people out there who know AI much better than I do. So, I mean, no means an authority. I mean, no way like an authority on this, but I think you should just kind of start doing it. Um,
Hmm.
it depends on what kind of person you what you want out of this. If you are, sort of like practical person and you just want to get certain results done and not care about the theoretical um, intricacies of what's going on, under the hood, then you can get started pretty easily. Just download some framework and just get started right away.
Yeah,
But
I guess
if you're like me, then you're just gonna have to probably read a couple books and just brush up on your calculus, linear algebra.
probabilities,
Uh,
st-
it, it-
statistics, maybe, or that is more of a data scientist thing.
yeah, it's like you have to learn a little bit of math if you want to learn the theory of what's going on under
Hmm.
the hood.
True. I guess for students or for CS students, the most important part is the theoretical one. I mean, if you want to do research, but for practical side, it is more of a business side. I mean, if you're working
Yeah,
AI, you're you're making I mean concrete projects. That is more of a business project, not a research project.
yeah, it is. I mean, if you want to, I'm more inclined to research, so I don't
Hmm.
really care so much about creating a solution using existing tools as much as I do about trying to think
Understand
about
the
new
tools and
tools.
makes new tools. Yeah.
Yeah, exactly. So, if you're more inclined to research, then you have to learn a lot of math
Mhm.
and programming as well. Just make sure you learn the fundamentals really well. Uh, and if you just want to do, business or use the existing tools, then, YouTube is your friend. That's one thing. And GitHub,
Yeah.
that's that's another.
Yeah, there are some super interesting repos out there about artificial intelligence, about open source projects. It is really helpful. Like the GitHub community is really helpful.
Yeah, it
I don't
is.
know how our dads and I mean our fathers and teachers used to learn without GitHub, without Stack Overflow, without YouTube. It was tough, I believe. I mean
Yeah,
there were books, but it was not as accessible as now.
yeah, I can't imagine.
Hmm. So
Have
I
you
guess
heard of the
sorry.
Chinese? Have you heard of the Chinese room argument?
The Chinese, no. I've not heard of that. So can you just say what is it?
Basically, it's like a thought experiment, uh, in AI, and it's just about this really cool scientist who just says, let's say that I'm locked up in a room, and you pass me some Chinese writing under the door, and then I just take all that Chinese writing, I take all those symbols, and then I have a book where I can look up basically the translation of that phrase. So I just look for that phrase, and then I just return to you the translated, version of that in English, and then I just pass it back under the door.
Hmm.
Uh, would that mean? Would that mean that I actually understand Chinese when I translated that? Would that mean that I have any understanding of those symbols?
No, absolutely not. Because you're going to, I guess you're just going to assemble those shapes, and then you make out a letter in English or a character or a sentence, and then you push it back. So I don't think you're mastering Chinese or you're understanding Chinese. You're just recognizing shapes and you are sending them back.
Yeah, exactly. So it's like the entire conclusion is like human minds or human brains do not follow, computer like processing,
Mm-hmm.
right? So it's not as rigid as the algorithms that try to just do if then statements. It's just a lot more than that.
Mm-hmm. So
It just
if I
results
get
from,
the konnichiwa, if I get the konnichiwa shape, then it's hello. If I get
yeah.
so, it is not how it goes. Yeah. Mm-hmm.
So like what this guy's trying to say is that this inner biological thing that's going on in our heads, it's not something that's computer like. So the best thing we can do is just to simulate the entire thing.
Mm-hmm. True. Nice. That is really nice. Like we've learned a new thing. So today we had the definition of AI, different areas and branches. We've talked about neural networks. We have talked about the Chinese room argument, some perspectives and philosophical aspects of AI. And this was our 101 episode of AI, until artificial intelligence, with Boudah Yahya, a friend from Constantine, ACS student. So I guess we are coming to the end of this podcast. We have made around 40, 50. I don't really know. It was so good that I just forgot and I lost the track of time.
Yeah, me
Thank you.
too.
Can you just, you have the final word to the audience?
I don't know. Okay.
Learn a lot and be curious, I guess. Ask a lot of questions.
Yeah.
That's the key. I mean, your AI journey started with asking questions. How does the brain work?
Yeah, I guess.
Mhm.
So and just don't rely. Just try to think for yourself.
Mhm. Yeah, you're just making it super interesting that I guess I'm going to start learning more about AI because I'm more of a software engineering guy.
Yeah, you
So-
should. I mean, I remember when I came to your house once, and then you started making fun of me. What is this? What's that you're learning? You should probably go learn, backend development or something.
or Java or C sharp or
Yeah, something that's tangible. That has a real value in the market.
yeah. So thank you so much, Yahya. I hope I can see you in the upcoming podcasts. I
Okay.
hope you enjoyed this podcast. I did, and it was really good. And that's it. Thank you guys. See you soon. Stay tuned.
All right. Bye.